Thank you for joining us. And this is the discovery session of our MIDD Plus conference. I am Eric Jamois, Director of Business Development at Simulations Plus, and I'm going to be your host for the best part of this morning. So I think we're going to give maybe a 1 minute grace period for everyone to get situated in this discovery track. So if everyone can find their seat, then we can get started. And so without further ado, it is my pleasure to introduce David Miller. David is our Vice President of ADMET Cheminformatics. And David is going to provide us with an introduction to the ADMET Predictor platform. David, the floor is yours.
Okay, thank you, Eric. Let's see if I can share my screen here. Okay, so thank you, and thank you all for attending. There is a lot of material that I would like to try to cover today in a pretty short time frame, so I am going to jump right in. ADMET Predictor is a multifunctional discovery platform comprised of the four main elements shown here. The most well-known is property prediction. There are now more than 175 properties predicted from chemical structure in these main categories. Physicochemical includes pKa, log P, solubilities, permeabilities, and so on. Metabolism focuses primarily on cytochrome P450s, but also covers UGTs and aldehyde oxidase. There are enzyme-specific substrate, non-substrate, and inhibitor, non-inhibitor models, kinetic models for the 5 major CYPs, and models of overall intrinsic clearance in both liver microsomes and hepatocytes. Transporters includes substrate, non-substrate, inhibitor, non-inhibitor, and KM models for key transporters, including PGP, BCRP, OATPs, OCTs, and OATs. Toxicity includes Ames mutagenicity, cardiac toxicity involving HERG, carcinogenicity, and several others. And finally, we provide a number of customizable risk scores that predict overall ADMET liability in the form of a single number. The predicted properties here are based on machine learning models built on training data acquired from collaborations, commercial databases, or literature. Our user manual provides details on the data sources, curation protocols, and model performance. The estimates provided in our so-called high-throughput pharmacokinetics module are not based on QSAR models, but rather mechanistic simulations in virtual human or rat species. The simulations are similar to those from our company's GastroPlus software and allow estimation of fraction absorbed and bioavailable and several important pharmacokinetic parameters. You can generate concentration time profiles and estimate the dose required to achieve a target plasma concentration at steady state. We have made a number of improvements to this module in the past year as part of an ongoing collaboration with a large pharma partner, and we will discuss that in more detail at a separate talk about 1 hour from now. Our model building engine allows clients to build machine learning models using their own data. The module provides our proprietary set of over 340 molecular and atomic descriptors. It supports both regression and classification models, and regression model estimates come with an accompanying uncertainty estimate and classification predictions with a confidence estimate. And then finally, our cheminformatics module includes many tools useful throughout early discovery in particular, like organizing compounds by common scaffold, R group decomposition, similarity, match molecular pairs, and so on. There are also features to help design novel compounds, including a new one called Artificial Intelligence-Driven Drug Design, or AIDD. And we will have a separate talk on that module in about an hour and a half. There are four main options for deploying ADMET Predictor. The command line version runs on both Windows and Linux and focuses on the ADMET property prediction and pharmacokinetic simulation features. We have clients who use the command line version to build web services and to power other graphical interfaces, such as Spotfire. ADMET Predictor's property prediction engine can be included as an optional module within our GastroPlus software to provide estimates of properties for which you do not have experimental data. The ADMET Predictor installer includes both KNIME and pipeline pilot components, as well as example protocols. And then finally, the graphical interface version offers a highly visual and interactive environment to more fully analyze and explore your chemical data. Note that this version at the moment is Windows only. Okay, for the brief remaining time, I'm going to give a quick tour through most of the main ADMET Predictor features available in the graphical interface version. For a more detailed discussion of the models and methodologies, etc., we would invite you to watch some of the many recorded webinars on our website. A few key takeaways I want to mention up front. First, the functionality spans early discovery through preclinical, and I'll progress in roughly that order during the demo. And then second, the very fast calculations and the flexible license policy means that a single license allows simultaneous use by an entire organization. A license is not required to start the software, open a data set, and perform a lot of basic analyses. And where a license is required, we are liberal in allowing it to be checked back in and made available to others while you continue your work until the next time you need to perform a checkout. Okay, so with that, I'm going to bring up ADMET Predictor. We're going to start with an example where you have a large number of chemical structures, such as might be the case in early discovery, where you're performing large-scale screens. For demo purposes, I'm going to use a set of 25,000 compounds from the Chembl database. Predictor can open SD and SMILES files. I'm going to use what's called an XTK file, the native format for Predictor. It's quite small in size. It has detailed session information and can easily be shared with colleagues. Okay, so the file opens pretty quickly. You see a table of structures, some ADMET property predictions that have already been computed, heat map coloring of those predictions. You have interactive charts that can be docked and moved around and so on. Even though the table has 25,000 entries, you can scroll through it very quickly with no lag. You can alternate between a more compound-centric view or the default table view with the columns. It's worth repeating that no license is required to open this set, visualize the structures and the predictions, or to perform basic operations like searching, sorting, charting, import, export, and many others. Okay, I'm going to start with a few kind of basic cheminformatics features. The substructure search functionality in Predictor is extremely fast. There are a number of options for query input. You can draw using MedChem Designer, which is our integrated sketch tool, paste from a tool like ChemDraw, load from file, type a query such as Daylight Smarts. I'm going to load a generic steroid query. The search is practically instantaneous. You can show the hits in a separate window. There are 702 of them. You can look at a property profile. This is our predicted log D, red showing the 700 steroids versus blue the whole data set. You can visualize them in the scatter plot, either with the rest of the data or in isolation. Another useful basic feature is assigning numeric scores to compounds, which is helpful for prioritization. An example would be scores representing the number of substructures associated with toxicity, say, or reactive metabolites. The predictor installation includes files defining these substructures. To use one, I would use add compound attributes, all rows, and then select query. I'm going to open a file called reactive metabolites. This file contains about 40 substructures defined from the literature, references shown here. You can, of course, edit this file or create your own files. So doing this operation involves 25,000 times 40 is about 1 million substructure searches, but it's extremely fast. Each compound is assigned a numeric score that represents the number of substructure violations, and the names of those violations are shown in a separate column. One kind of nice feature is you can show the histogram of the violations themselves. So you can easily see which compounds have which violations. So I could click the first bar and see the 61 compounds that are flagged for the 2-halopyrimidine motif. If you want to actually see the relevant substructures highlighted, you could just do a substructure search using that same file. It's 1 million searches, and now you see the relevant motif highlighted. Okay, dock that. When dealing with a data set of this size, it's useful to organize it into chemical families. In ADMET Predictor, you can activate a separate classes tab that gives you a lot of flexibility in performing that organization. The simplest is to use one of the built-in algorithms. The default one, called Frameworks, is based on the well-known approach described in the paper by Bemis and Merco, where scaffolds are comprised of ring systems and linkers. Again, it's very fast to run on this 25,000 compound set. Roughly 1,000 classes were identified. Each is represented by one row in this tab. If I double click here, you see that the common scaffold for the class is shown in blue. You see the number of compounds in each class. You can optionally add property histograms. This is predicted log D and permeability. And you see that the classes are automatically organized so that classes with similar scaffolds are placed next to one another in the spreadsheet. You can perform substructure searches here in the classes tab. So if I repeat that steroid query, you see that the software identified a number of closely related steroid scaffolds all grouped together. If you wanted to combine these into a single steroid superclass, you have the flexibility to do that. So now there's a single steroid class with 702 members. If you want to add classes using scaffolds that you have drawn yourself, there's an option to do that as well. So here I'll launch our sketch tool. This is MetChem Designer. I'll clear that and load some previously drawn scaffolds, some Marcouche and some exact. I can just transfer those back to Predictor, perform that search, and then the software will add a new class for each of the scaffolds that was actually present in the data set. So you see you have a lot of flexibility to organize the compounds however you like. Okay, so For the remainder of the talk, I'm going to focus on a single chemical series, and I'm going to choose this class of 158 benzodiazepine derivatives. The first thing I want to quickly do is just reorient these things to be somewhat more conventional and make sure they're all aligned to the scaffold, because in the Chembl database, they're drawn in all kinds of different ways. The two steps to do that would first be to reorient this single compound. This is the lowest molecular weight compound shown as the representative. If I send that to Designer, I can simply click a redraw here. Designer can be configured to draw designated scaffolds in a desired way. I've done that, transfer that back. That changes this compound. Now I can just do an alignment. So every compound is aligned in the same way. Now I'll bring them back to the Compounds tab to show just those compounds. Everything else, 24,000 plus compounds are hidden. And you see they're all aligned in exactly the same way. The last sort of cheminformatics-like feature I'll show is related to similarity analysis. There are many features in that category in Predictor. A pretty novel one is to perform a similarity search against an external database. Predictor allows you to create these searchable databases using any collection of compounds, like a corporate collection or a vendor collection and so on. I'll illustrate this using, again, the lowest molecular weight compound in the class. If I launch that option, similarity search, I see a few databases here. I'm going to select a 5 million compound subset of the PubChem database that I previously created. You can set similarity criteria here. Searching 5 million compounds. It's extremely fast. It's even faster if I weren't doing a Zoom broadcast. The hits are brought back into a separate instance of ADMET Predictor. There's about 2,500 hits. And if you view them in a special tab called the Pairs tab, you see two columns. The left is our query structure. The right are the database hits. All the hits are aligned to the query, and the structural differences are highlighted in blue, blue and red actually. The most similar hits are at the top and least similar at the bottom. So you can see at the very top, there's an exact match in Chembl, and then there are matches that are close but a little different, but you notice the highlighting. I just had one example, just scrolling through it, to show this one. Somewhat non-obvious with a very different ring topology. So that's kind of the point. This feature is useful for generating new ideas, checking for novelty, and so on. All right, I'm going to close that and get back to Predictor. Now I'm going to shift to the prediction of ADMET properties. The workflow for that, again, all compounds. I'm going to focus on this 158 set, just the benzodiazepines. You start by selecting the categories of the predictions you would like phys-chem, transporters, and so on. The only other option you might ordinarily modify is the pH value for the log D and the pH-dependent solubility predictions. The calculation time is very fast on this set. For the full set of 25,000 compounds, it takes about 2 minutes on this 6-core machine. So the result is a large set of prediction columns, which you can view together or in their respective categories, like phys-chem, metabolism, and so on. Optionally, the software will generate a set of what are so-called star plots. These are multiple predictions represented graphically in a single column. So the SIP substrate plot, for example, shows by the filled wedges the SIP isozymes for which this compound is predicted to be a substrate. And you can configure these plots however you like. I'm going to show a few columns here and just reiterate that for our classification models, we show in the spreadsheet by default a percentage confidence score, which you see here. And then optionally for regression models, we show the analogous uncertainty information. That's represented as a 1 sigma lower and upper bound. The user manual has detailed information on the theory behind these two estimates. Predicted values are marked in red and underlined if they are out of scope or outside the so-called applicability domain of the model. And we advise that these predictions be used with caution. I'll quickly show the distribution of ADMET risk scores for this set of compounds. We observe that about 90% of orally bioavailable commercial drugs have an ADMET risk score of 7 or less. So these compounds all have relatively low scores. If I view the histogram of risk rule violations, you can see what those are for this set of compounds. The dominant one is labeled KOW, which is octanol water partitioning. So these would be the compounds that have relatively high predicted log P or log D values. You can, of course, modify our ADMET risk rules, or you can create entirely new risks, risk models on a project-specific basis. Okay, there isn't a lot of time to discuss individual predictions at length, but I want to focus for a minute on our pKa predictions, which are very highly regarded. These were the top performing QSAR predictions in the recent Sample 6 pKa challenge, the results of which were just published in the Journal of Computer-Aided Molecular Design. I'm just going to show the columns of the macroscopic pKa predictions. In addition to these, you can also see predictions of the individual ionization microstates for a given compound. And I'm going to just quickly illustrate that using a compound that has both basic and acidic groups. I'll do an exact search. So with this compound selected, if I launch our pKa microstates viewer, just magnify that a bit, our macroscopic pKa predictions are listed here in descending order. So you see that at a pH above about 4.2, we predict the single fully deprotonated species. And then in this pH region, for the zero charge state, we predict an equilibrium of multiple microstates. The dominant one being fully neutral and the others being zwitterionic. We provide estimated populations for these microstates, which you can also view as a function of pH. So this chart represents all of the ionization microstates, and you can also view the corresponding macrostates. So this would be the -1 charge state here, the 0 charge, which is the sum of these microstates, the +1 charge, and so on. Related to ionization, we have features to predict log D and solubility as a function of pH. So for that same compound, I could show the predicted solubility curve, and it's the characteristic zwitterion shape where the minimum solubility is in the pH region where the compound is predominantly neutral. Okay, another useful feature is metabolite prediction. This makes use of both our substrate, non-substrate models, as well as our metabolic site models. I'm going to use a different compound, the drug alprazolam, to illustrate that. If I select that compound and launch what we call the atomic properties window, I can see a prediction of, for example, the 3A4 sites of metabolism, showing the 2 that we predict. And I can show the analogous predictions for the 3A4 intrinsic clearance predictions. To see the prediction of actual metabolites, The most visually appealing way is in our MedChem Designer software, the Sketch tool. So if I send that compound over to Designer, there's a lot of functionality in Designer. One of them being to predict metabolites. It's not just CYP, they're actually UGT and esterase as well. So you see we predict 2 3A4 metabolites. Both of these are experimentally observed. Because of the quantitative intrinsic clearance predictions, we can actually also predict yields for the metabolites. Among the other pieces of functionality in Designer, you can do the full ADMET property prediction here as well. So I can quickly predict all the ADMET properties for the parent compound and the 2 metabolites. This is very useful for, exploring structure changes and then quickly seeing the effect on the predictions. Okay, back to Predictor. I said that at the top of the hour, we would have a separate talk on HTPK, on the pharmacokinetic simulations. I'll just briefly illustrate the workflow on the full set of 158 compounds. So here I'll choose human species, immediate release tablet as the dosage form, a dose of 1 milligram. Other parameters like the intrinsic clearance, there are several on an advanced tab like log P, solubility, permeability, and so on. These are all ADMET Predictor predictions by default. If you have experimental data, you can use it. You can also use your own models. Again, it's fast to run on this set of 158. It's about 2.5 minutes for the full set of 25,000 compounds. A related pharmacokinetics feature is the ability to generate the concentration versus time profiles. You can do this from either Predictor or Designer. I'll do it quickly in Designer. I'll launch alprazolam again. I'll do a default curve using the same parameters that I just used in ADMET Predictor. So you get a curve like this, which is actually a pretty reasonable result when you compare to experiment. One of the extensions that we made as part of the collaboration was to allow you to view multiple series within the same window. So for example, if I wanted to compare that to IV bolus dosing, I could make that selection and then choose attach to the existing window. And then that allows an easy comparison between the oral and the IV. One other extension was to handle multiple compounds at one time. So in Designer, you could simply create an analog and then view them both together in one CP time window.
So David, we've just really got a couple minutes left to conclude here in the session.
Good timing.
Yeah, very good timing.
I knew we were running a little late. I apologize. I know that was a lightning fast tour of ADMET Predictor, but I hope it gave you a sense of the ease of use and the amazing breadth of functionality. So let me show the last slide here. We may have time, I don't know, Eric, for a question or two, but if not, here are the 2 email addresses. Feel free to send any questions in. So thank you again. I'll pass it to Eric.
Yeah, sure. Great introduction, David. Thank you so much for sharing this with us. I'm looking at the chat window both and the Q&A pane. I see a couple really nice comments in the chat from I think several users who like the PK and solubility models that we provide, but I don't see any specific questions in the Q&A. So unless someone has something else, I'm going to close the session and switch the presentation over to Bob Clark.